Okay, so let's see 4.4, non-homogeneous equations. So we're gonna learn the method of undetermined coefficient. So some coefficients is involved in the solution to the equation, and we're gonna determine the coefficient. Okay. So let me start with the let me introduce the differential equation first. So non-homogeneous means that in mechanics, or sorry, in engineering, the external force is non-zero. Okay. So what AY dou prime plus BY prime plus CY is equal to F of T. So this F of T represents external force. So this example, okay, let me, you may just try to find the Ox equation, but um, it's not gonna work. Why? Let's see this example. So y second derivative plus 2y prime now plus y is equal to t. See that? The right-hand side is not just 0, but t. Polynomials, actually monomials. Okay. So then you may say that, okay, why don't you just, assume that y is e to the rt? I told you it's not going to work because the derivative of e to the rt is, r times okay, sure. Y prime is what? R times e to the rt. And the y second derivative is equal to r squared times e to the rt. So when you substitute these three functions into the differential equation, I mean left-hand side of the differential equation, we're not going to get t. Because this is the exponential function. That's the exponential function. That's the exponential function too. There is no way to get the polynomial on the right-hand side. Right? Okay, it's not going to work. Okay. So let me guess. To get the polynomial, monomial t, then y of t probably a times t. I'm just guessing, okay? All right, then y prime going to be a, and then y second derivative is 0, right? Maybe we can get t on the right-hand side when we define a solution as by a times t. Let me try, okay? So literally, I'm just giving a shot, okay? So then second derivative is 0, right? 0 plus, and then 2 times, a prime, y prime is just a, and then plus at is equal to t. Okay, so which means that 2a must be 0, and then a must be 1, right? It's a contradiction. A must be 0, a must be 1. Doesn't work. Okay, I need, two unknown, or you can say undetermined coefficient, right? Okay, then we try. Okay, that doesn't work. It doesn't work. So what about this? What we define what is at plus b. Okay. The reason that we got only one unknown undetermined coefficient because we define as a single term with one single undetermined coefficient, right? So now we got two undetermined coefficient. Then we find the y prime, y to third prime. So y prime is going to be a, and then y dou prime is 0. Using this one, then we got 0 plus 2a, right? And then plus at plus b. This is, it must be 0. Okay, t, sorry. So now see that here, then 2a plus b must be 0, and a must be 1. Now it works. What is it? So now here, okay, so I think this idea is quite good. So I want to generalize this idea for any function as external force given. So which means that we can define general solution by looking at the type of solution of the external force. If the T is given, you see that if right external force, the type of external force is polynomial, then solution the form of the solution somewhat like this. If the external force is not just polynomial but exponential function, then yt must involve the exponential function or exponential term. I mean, if this is sine or cosine, then yt must be sine, cosine, something like this. So that's the main idea of the method of undetermined coefficient. Now we see the y undetermined coefficients that this is in the name in the the method, because you see that once we define the general solution like this by looking at the type of the external force, and then we're going to determine the undetermined coefficient a b. So let's see example. Okay, so the first one, case one, right here. Case one. So ay dou prime plus by prime and a plus cy is equal to c times t to the nth power. I'm just generalize this idea. So you see that c times t to the nth power. Okay, n could be 0 and 1 and through here just positive, non-negative integer. Okay, so this is a monomial. All right. Okay, in this case, in that case, okay, then the particular solution, particular solution doesn't mean the particular solution in initial problem. So here the subscript p means the a specific solution to that differential equation. Okay, keep in mind that subscript p doesn't mean the particular solution to the initial value problem. We are not solving initial value problem. We are solving just a differential equation. Okay. So here y sub p means a specific solution. It has the form a times, see that it t to the m's power. Then the specific solution has the form with the m's power, the degree m polynomial actually. The plus a m minus 1 and then t to the n minus 1 through the a and then t and then plus 1 and then a is 0. Okay, right here. Okay. Okay, we got problem actually. The okay. The what if the external force is not just monomial, could be monomial times exponential function, or monomial times trigonometric functions. So let's figure out that. Okay. Before doing that, let's see one more example. So y dou prime and then plus y prime and then plus 2y is equal to 5 times e to the 2t. Okay. See that right here? The exponential function is given. And then let's say we just try. Okay, let's say a should be a times e to the 2t, because e to the 2t must be involved in a solution. Otherwise, we're not going to get exponential term, right? You may say that, okay, why don't you just try, yp is defined by polynomial. Polynomial never, the return or generate the exponential function. So, okay. So, all right, then using this, then yp, dou prime plus yp, prime plus 2 times yp. This one going to be, let me just keep, the process in the middle right here, and then we get this 5 times through I'm sorry, so 8 is 8 times e to the 2t. This one must be equal to, must be equal to what? The external force, 5 times e to the 2t. So A must be the 5 over 8, 5/8, right? Okay. So the other one, I mean, before going over, so from here we can generalize the this idea. Okay. But before doing that, we need to something to something to keep in mind that you know okay, let me give you an example before explain more. So easy example. So what about y second derivative plus 3y prime plus y is equal to cosine t. So okay, so similar to what we did in previous example, in this example, so we may define the solution yp as the a times cosine or sine, but think about this. The derivatives are involved in definitely derivatives are involved in the left hand side of the differential equation. So in certain term we get the sine, in a certain term we're going to get cosine. So yp must be a times cosine t plus b times sine t. Okay, we're not going to just define yp as a single trigonometric function, cosine or sine alone. We need both because the derivatives eventually we'll take a derivative. Okay? So see example. Okay, let me just look at the solution. In this case, the yp implies yp dou prime plus 3 times yp prime and then plus yp is equal to right here a plus okay b 4 times b and then cosine t and then plus b minus 4 times a sine t. Okay. This one must be equal to what? Cosine t. So which means that this must be 0. This must be 1, sorry. And then this one must be 1. 0. I'm sorry. 0. So A, you can find the A, right? So A is the so right here. So A is 1 over 17. And then B is the 16 over 68. So YP is T is 1 over 17. And then cosine T. And then plus 16 over 8. You can simplify this fraction, okay? Let me just leave it, okay? Because that's not the matter. That's the solution, the particular solution, actually. Yeah, I mean, specific solution here. So now you can see that, okay, so if the external force is sine or cosine, then particular solution must be C1 times cosine t plus C2 times sine t, or you can say A times cosine plus B times sine. Okay. So now what are you going to do? See example, other example. What about this? External force is not just, sine, cosine, but maybe, product of the functions having distinct type of functions. Something like this. 5 times, for example, e to t. You see that 5t is a polynomial, e to t exponential function. So two distinct type of functions are multiplied. What are you going to do? All right, so in this case, yp is going to be, we define this one as at plus b, because, we know that to get the 5D, y must have some polynomial with degree 1. So at plus b must be perfect to get monomial 5 times t, right? And then just times e to t. Okay? Because derivative e to t is just e to t. So I'm sure that we'll get e to t when you put e to t in the yp. And then taking, even we take a derivative yp twice, we still get e to t. So, okay, I think it will work. Let's figure out. Let's figure it out. So, then what? Yp lower prime plus 2yp and then is equal to what? What's going to be like that? So 2a plus 3b, okay, and then plus 3at and the e to t. You see that? Then which means that 2a plus 3b must be 0, right? And the 3a must be a 5. Now, so a and b can be determined. So actually, so a is the 5/3, and then b is 15/9. But minus 15/9, sorry. Minus 15/9. Okay. Okay. All right. I think it works. You can generalize this, right? So what if we just, c times exponent for c times t to the m's power and the e to the, for example, 8 alpha, we use alpha, right? So maybe, uh, uh, yeah, let me just use alpha, okay, alpha t. Okay, then from there, then the form of the specific solution must be, the degree m polynomial, a m and t to the m's power through the a0, and then times e to the alpha t. I'm sure that the yp must be defined like this. So we can generalize this case. So I'm sure this, but here's an example. Okay, I mean, here's one thing that we need to consider the other things. Y second derivative minus 6y. Now you see the pattern, right? Plus 9y is equal to e to the 3t. Now, okay. So I know. So you don't see the difference between these problems and that problems. See? Oop, all right. It was nice, sorry. Okay, so we just let's say a specific solution be 8 times e to the 3t. Then we're gonna get a big problem. The thing is that actually 3 is the root of the ox equation associated with the homogeneous equations. So what that means, the associated homogeneous equation associated with that differential equation is this: y second derivative minus 6y prime and then plus 9y equals 0. And just consider this. I think I'm going to put this one down here. So then the ox equation is going to be the r squared minus 6r and then plus 9 equals 0. So r minus 3 squared equals 0. Right. So r is 3. Okay, that means what? The general solution, I mean, a solution to that homogeneous equation is e to the 3t. Right? So this is exactly the same as the external force, and a times e to the 3t is the scalar multiple of that solution. It means that when you substitute this one into differential equation, we should get 0 for any choice of a. So that cannot be a solution to that non-homogeneous differential equation. So we're gonna find out a solution, I mean function, which is linearly independent to this. One of the simple choice is gonna be we just put t between a and e to the 3t. So that's the could be a solution. Okay. So by the way, so let me give let me tell you the terminology for this one, r equals 3. So we got the only one repeated real root, right? This is called the double root. Okay, so what if we got two distinctive root? That's gonna be simple root. Keep in mind. So now then y of t is gonna be the a, let me see, sorry. So now then what? The a times t times e to, oh, sorry. This is also, look at this. We got this one, right? Y1. Then general solution, I missed one more things. C1 times C1 times Y1 plus C2 times Y2. In this case, that we got a double root. Y2 was the is what can be defined by t times y1, isn't it? So we got c1 times e to the 3t, and then plus c2 times t times e to the 3t. So e to the 3t, the t times e to the 3t is also the another solution of that homogeneous system. So we put one more t. So we got t squared. I'm sorry. Yeah. Okay. So I made a mistake. So that must be a solution to that non-homogeneous differential equation, because e to the 3t, t times e to the 3t, both are solutions to that homogeneous differential equation. So we need one more t. Okay. So then it works. So doing you can determine a. So a is the 1/2. Okay. So so when you generalize this idea, okay, we in this example we generalize the idea, right? But we need to consider this case too. So finally the see let me describe the method of undetermined equation. All right. Here. Okay, so case 1, ay dot prime plus by prime plus cy is equal to c times t to the m's power and the e to the rt. So in this case, what we got this one, right? Okay. Here's one more things. What if this one is a solution to the homogeneous differential equation? So we need to consider that case. So, in that case we need to avoid the the case that YP turns out to be a solution to homogeneous equation, we need to put that term t to the s power, and then e to the r. So e to the tm, e to the rt. Sorry, to the rt here. So e to the rt. Yeah. So if r is not a root, Okay, R is not equal to a root. The aux equation. Then S equals 0. Okay. And then if R is what? R is a simple root. Okay. Of the associated aux equation, then S is equal 1. Okay. That's enough. As we set S1, if R is a simple root, because R is simple root, that means in homogeneous differential equation, we got two solutions, right? Y1 and Y2. Y1 is e to the R1t, and the Y2 is what? E to the R2t, right? So it's enough to set S1 to get a solution which is different, which is linearly independent to these Y1 and Y2. So if R is a double root, okay, then S must be 2. S equals 1, then S is equal 2. Okay. The second case, AY dot prime plus BY prime plus CY is equal to C times T to the m's power, and then cosine E to the alpha T, and then cosine beta T. And then C times T to the m's power, E to the alpha T, sine beta T. Okay. Then the form of the particular solution, Yp of T is going to be T to the S power, and then polynomial. So we're going to get the T to the S power and the polynomial times E to the alpha T and the cosine plus T to the S power times, the another polynomial for this one times E to the alpha T and the sine beta T. Okay. So plus through the A0 and then E to the alpha T and then cosine beta T. Okay. Now plus T to the S power and then Bm and then T to the m's power plus B0 E to the alpha T and then sine beta T. Okay. In this case, you see that here? E to the alpha T cosine beta T, and then these are what? This is solution to the homogeneous differential equation, right? This is also a solution to homogeneous equation, right? So it means that if alpha plus I beta, okay, here alpha and beta is from the that alpha and beta, okay, that this alpha and beta from the external force. If this is equal to a root, actually complex root, right? Yeah, but okay, just root. Okay, root the associated aux equation. Then S equals 0. Oh, not equal. Sorry. Okay. If alpha plus I beta is a root, but in the case that the homogeneous equation has complex root, we only have two cases. Yeah, distinct. I mean, only one case, distinct complex root, right? So if alpha plus I beta is not equal to a root of the aux equation, the S equals 0, set S equals 0, And then if alpha plus I beta, which that one from the external force is a root of the ox equation, then what? S must be 1 to make it to a function which is linearly independent. Okay, right? So let's see example. Let's see. Okay, so let's see example. Let me choose a simple one. So example. So y is second derivative now plus 4y is equal to 16t times sine 2t. Let's see. Exponential, I mean, sorry, it's polynomial, monomial is given. Monomial times exponential, no exponential term, right? But we can say, 16t times e to the 0 times t, right? So from here, we can see that the alpha from there, alpha is 0 and then beta is 2, okay? Right. So step 1, definitely we need to check if alpha and beta are equal to the alpha beta from the solution to homogeneous equation, okay? So then to figure out that, we need to find the Ox equation first. So r squared plus 4 is equal to 0. That's Ox equation. So r is square root of -4, which is a 2i. Okay. So it means that what? Here, let me use the alpha prime. Okay, alpha prime is 0 and a beta prime is 2. This is exactly the same as the alpha beta in the external force, right? So this guy from the Ox equation, from there, homogeneous equation. So the y of t, which is a solution to general solution to the homogeneous equation. Y of t is going to be c1 times, right, e to the alpha prime t, right, times cosine beta prime t plus c2 times e to the alpha prime t, and then sine beta prime. Okay, so alpha prime beta prime from the homogeneous equation is exactly the same as alpha beta in an external force. So we figured out that it means that what? S must be 1. So keep in mind that. So in step 2, we just write the form of the solution to that non-homogeneous equation based on method of undetermined coefficient, which is this one. I didn't. Okay, this one. So let me copy it here. This one. Okay. Paste. Right. Okay. So here we need to figure out the parameters m and alpha, beta, and s. Okay. So first one, m is what? So m is the degree of the polynomial, right? 1, right? M equals 1, and then alpha is the 0, and then beta is 2, right? Beta equals 2. And now s is what? 1. Okay. So we figure out the parameters. So yp of t is going to be t times, right, the a1 and t plus a0, and then cosine 2t, and then plus t times b1t plus b0, and then sine 2t. Now we figure out these are undetermined coefficient, a1, a2, and the b1 and b0. These are undetermined coefficient. Okay. So how can you figure out these undetermined coefficient? Substitution. Just substitute, okay? Just substitute the yp into the differential equations. So then we're gonna get the equations for a1, a0, b1, b0. Okay. So that's the yeah, that's the that's the way to solve the find the solution. Okay. So the doing that, really, this the step that was a step 3. 3 was yeah, find a1, a0, and b1 and b0. Okay. So doing that, okay, let me skip it because this is tedious. So b1 is 0, and then b0 is 1, and a0 is just 0, and a1 is -2. Okay, that's it. So now then yp is what? It's going to be 2t squared, cosine 2t, and then plus t squared sine 2t. I told you this is just a sine 2t. So this is just a specific solution, but we're gonna find out general solution. How can you find the general solution? What we did so far is was to figure out how to find out a solution to that a non-homogeneous equation. So to find out general solution, y of t is actually what? The yp, which is a solution what we got using the method of undetermined coefficient plus yh. This is the a general solution to the homogeneous equation. Why? Because the general solution means that what? On the constants of integration must be involved. So yh has c1 and c2, right? Okay. So and then also y of ht must be a solution to homogeneous equation. So it will not affect on the external force on the non-homogeneous equations. So that's why that works. We can say this can be a general solution to the non-homogeneous equations because this is a general solution to the homogeneous equation. So this one contains C1 and C2, constants of integration. Okay, and then even though we substitute this one into non-homogeneous equation, that will return 0. And then this one, plugging this one into the non-homogeneous equation, that will return the external force. So the yt will return the external force when you plug in this one into the non-homogeneous equation. So that works. So that one, and then also this theorem guarantee that this a solution to the general solution to the non-homogeneous equation. That theorem is a superposition principle. Okay. So okay, about superposition principle, you're gonna hear this one a lot in other field, engineering field. Okay, superposition principle means that the combining the solutions can be the solution to a equations. Okay, so you may just search the broad way of the broad concept of the superposition principle by yourself. So I'm gonna stop here. Okay, let me just wrap it up.